Alright, in this video we're going to be working with rational expressions, and this is something you'll need to be able to do in Chapter 5. So number 1, in order to add these, we need to get a common denominator. So basically we're going to multiply 1. Well, to get a denominator of 9, I need to multiply by 9, and we'll use 9 over 9 so that we're not changing the value of the 1 that we started with. We're going to get 9 over 9 plus 16 over 9. And so notice 9 over 9 is still 1, which is what we started with. This is going to be 25 ninths. Alright, on number 2, we need to get a common denominator. Now, we don't know what the denominators are here, so the only way to get a common denominator, or an LCD, is to multiply the two numbers together. And so we're going to rewrite these fractions so that they have a denominator of xy. Well, how did I go from x to xy here? I had to multiply by y, so I'm going to multiply the numerator by y. So again, what makes this legal is I'm multiplying by y over y, which is equal to 1. So this ends up being a 7y. Notice if I were to cancel the y's, I'd be back to 7 over x. I don't want to do that, though, because I need that common denominator. So similarly, I need an x, y here, and I only have y, so I'm going to need to multiply by x over x here. So this is 3x. We end up with 7y plus 3x over xy. And you would probably write the x term first, although it's not that big of a deal. Number 3. Again, we have a 1 here, so I need to get a common denominator of x squared. So I'm going to have to multiply by x squared over x squared here. So this is going to be x squared over x squared minus 1 over x squared. We get x squared minus 1 over x squared. And that's it. Now, if you remember the factoring we did, you might think, oh, I could factor that. And that's true. But there's really no reason to do that at this point. Let's move on to number 4. So in the same situation that we were in number 2, we don't really know what these numbers are, so finding a least common denominator, there's really nothing we can do other than multiply these two together. And so our new denominator will be x plus 2 times x minus 2. So I'm going to rewrite each of these with that denominator. Now notice to go from here to here, I had to multiply by x minus 2. So I'm going to do the same thing to the numerator. We get x minus 2 here. Over here, I had x minus 2, and I had to multiply by x plus 2. So 1 times x plus 2 is x plus 2. So now that I have a common denominator, I can add my numerators, x minus 2 times x minus 2 plus x plus 2 over x plus 2 times x minus 2. We're going to end up with 2x over x plus 2 times x minus 2. Now I could FOIL these out, but we're just going to go ahead and stop there. Alright, last problem. We actually did this in the previous video if you watched the one with radicals. We can write this as two terms, x squared y over xy minus xy squared over xy, and you get x, because the y's cancel, and x squared over x, that's just x. Here the x's cancel, you have y squared over y. Basically you have two y's here, and one of them cancels out this y, and you're left with just a y. So the x's cancel here, this y cancels, and you're left with just a y. So it's x minus y when we simplify. Alright, and that's it for rational expressions.